You're in Alberto. Alright, here we go. Please don't talk. Alec and Will and Jack. Here we go. One of the calculations that you need to do is to look for in terms of your magnesium oxide, you will have a theoretical yield and an experimental yield. Okay? What do I mean by that? So, in the process of this experiment, what you did is you took magnesium and oxygen and then combusted them to form magnesium oxide. So, theoretical yield means what is the mass of the magnesium oxide that you should have gotten? Okay? That you should have gotten. Then you also must calculate the yield that you got in your experiment. As in, how much magnesium oxide do you actually have versus your theoretical yield? So what I mean by that is this. Can someone tell me a mass of magnesium that they use for their experiment? Someone with their hand up, thank you. Marvin? 0.1. 0.1 what, Marvin? Okay. Shh. Okay. So, year 11, when we have a chemical reaction, we want to balance this first so that we know what proportion this has happened in. Is my chemical reaction equation, is that balanced yet? No. So there's 2 oxygens on the left-hand side, which means I need 2 oxygens on the right-hand side, which means I need 2 magnesium atoms per oxygen molecule. And so, with that, because I need to figure out how many moles of magnesium oxide I should have produced, I need to figure out how many moles of magnesium I'm working with. Because remember, chemical equation ratios are for moles and not for mass. And if you have a mass and you want to know how many moles of magnesium oxide or how much mass of magnesium oxide you will form, you actually need to convert it into moles and then from moles back to mass. Alright, how do I figure out how many moles of magnesium I have? The formula says what? You divide mass by molar mass. That's what the formula says. The formula says N is equal to M over big M. Yeah? So, the molar mass of magnesium, according to our periodic table that we use in physical sciences, says 24.31. If I calculate that, I will get how many moles of magnesium I had. Yeah? So, can someone do that for me? 0.173 divided by 24.31. 0.0. Give me another one. 711. 6. All right, cool. 4 significant figures. All right. So that's how many moles of magnesium Marvin started with. And this is where a balanced equation comes into play. If I have a balanced equation that says for every 2 moles of magnesium that I use, I will produce 2 moles of magnesium oxide, that's a 1-to-1 ratio. Does that make sense? No. For every mole of magnesium that I combust, I will make a mole of magnesium oxide. That's what the balance equation says. So, if I've just calculated how many moles of magnesium that I had, if I fully combusted it and everything went according to plan in a perfect world, then theoretically I should produce an equal number of moles of magnesium oxide because it's a 1-to-1 ratio. Or for every 2 moles of magnesium I've used, I have 2 moles of magnesium oxide because it's 2-to-2, yeah? Which is 1-to-1.
An equal number of magnesium oxide. So the amount of magnesium oxide would be the exact same as the magnesium.
In number of moles, but not mass, in moles. Because remember, mole ratio is different to mass ratio. Counting.
Amount of that substance at the atomic mass.
No, mole is 6.02 times 10 to the 23 of a thing. Yeah, that's what a mole is. Double that. Okay, so so that logic, so I'll write that here for you. Okay. No. Because that's a ratio. Don't double it. Because then you have double the amount that you had, which you don't.
Do we think this is burnt yet? It's been a long time.
Oh, yeah, that's different, yeah. Alright, can someone do for me 0.007116 divided by 2? Uh-huh. 0.003. Okay. I think everyone should pay attention to this because I think this can be a source of confusion for many of us when we're learning chemistry. Okay? I'm recording all of this, Thomas, so don't worry. Alright, so on my screen, what I have is the calculated amount of moles that Marvin used in his experiment. I got that from him measuring 0.173 grams of magnesium. So if he's got 0.173 grams of magnesium, that means he has 0.007116 moles of magnesium. And we did that by using the equation, number of moles is equal to mass divided by molar mass. And so remember, a balanced balanced equation is representing a proportion, a ratio. It's saying if I have two of these and one of these, then I'll make two of these. And if you think those numbers don't add up, how can two and one make two things? It's like if I had two buns or two pieces of bread and one sausage, I can make one sausage sandwich. Because two pieces of bread plus one sausage makes one sausage sandwich. Is that okay? That's a thing that works. So this equation is saying for every 2 moles of magnesium, I will need 1 mole of oxygen to form 2 moles of magnesium oxide, because that's the proportion that this chemical reaction works.
So what is the ratio?
That is the ratio. It's 2 to 1 makes 2 moles. The ratio is 2 to, well, the ratio is like this. You could write it like this. Yeah, so if you're just looking at the magnesium and the magnesium oxide, if I have 2 moles of magnesium, I should produce 2 moles of magnesium oxide. But 2 to 2 is the same as 1 to 1.
But if you're saying, just looking at that magnesium oxide, wouldn't you need the oxygen to be able to make that?
You do, but we're just looking at this and this because that's what you measured,
Okay, so
and you measured this as well.
right.
So what should happen is, if everything worked out perfectly, we would have an equal number of moles of either substance. You would have started with 0.007116 moles of magnesium, and because it's a 1-to-1 ratio between magnesium and magnesium oxide, you should produce an equal number of moles of magnesium oxide.
Yeah. Okay.
But that number is useless to us because what you did was you measured mass. So what you need to do now is take this value and convert it to, yes. So you want to then turn this number of moles of magnesium oxide that you should have produced into mass, so that you can now compare what should have happened to what did actually happen in your experiment.
So M equals M times M. The number of moles.
Yeah, so in your formula,
Amount of substance times the mole of mass.
the formula is like this, and we know number of moles, and we know molar mass, and we want to know actual mass or sample mass. So to rearrange that equation, you end up with mass is equal to number of moles times molar mass. And so for the mass of magnesium oxide subscript is equal to 0.007116 times the molar mass of magnesium oxide, which is the big M of magnesium oxide is calculated by adding the molar mass of each of those atoms, 24.31 plus 16, 40.31. So I'm multiplying this by 40.31. What's that equal to? What's 40.31 times 0.007116? I need to bring a calculator with me, don't I?
I thought you were the calculator.
That's racist.
Every time I say something,
Sorry.
you're a good man. Just a right.
Ruben?
Is the 40.31 just the atomic number?
No. Whoa. 40.31 is the molar mass of 1 mole of magnesium oxide. Atomic is 1 atom. Huh?
What the hell is that thing?
Magnesium and oxygen.
I don't know why it's 10 to...
Alright, so what's the calculation, Marvin? What's that, Marvin? 0.2868. Okay, we'll leave it there.
What is that?
So this number here is your theoretical mass. Okay?